Hey guys, welcome back to another episode of Classic Arcade Repairs. Today I have a Nintendo PlayChoice 10 PCB on the bench. And the cool thing about this is I can use my punch-out harness. The only difference is it has to be flipped 180 degrees, so this is the solder side on the parts side. Kind of strange, but yeah. I have it hooked up, and I initially just checked power, and my voltage is good. My 5 volts is good on here. I get just white screen, nothing going on. And I turned the scope on and just started probing around, and I'll show you. The first thing I did was I went to the address. What I assume are the address buffers, these two 244s here. And we'll look at inputs, starting at pin 2. Nope. That is, yeah, pin 2 is an input. So you have an in, that's its output. Anyway, here's 2. This is the next input, and input. Okay, input. That's an input. Another input. Input. That's all the inputs. I'm going to look at the inputs one more time. We have a low. The next one, we have another low. The next one, we have a signal. Good looking signal. The next one, we have a low. Next one, good looking signal. And then a good looking signal. Another good looking signal. Low. Low. Now our outputs, starting on pin 3. Low. Look at that. That is an output. Next. Remember, these are good looking signals on the inputs. And this is what we have on the outputs. Look at that. What is that supposed to be? I'm just going through right now and finding out this is an input to its output. Yeah, that's an output from this. I mean, yeah, it's low, but it's weird. Anyway, that's this chip right here, and I take it that's an address buffer. Question is something attached to that, the addressing, that's making it goofy, like a RAM, one of these RAMs or something attached to that that's really gooping it up. I don't know. I could remove the ROMs and see if it's still weird, which I think I'll do that. Why not? And this has a Z80, but I believe this is a Z80C, which is like an 8 megahertz Z80. I don't know if my flute pod will work on this, to be honest, because this thing's running at like 8 megahertz. I don't know. We could try it. But first things first, I want to remove the ROM, see if this still looks weird. I think we just have a bad driver here, so we'll see. I'll be back. Alright, I had removed the ROMs and it didn't change anything. But if you look here, I got my logic probe here. We will look at this is 1, 2, 3, 4, 5. Pin 5 is an output. And you can see This is the output to this input. Yep. And if we look at our logic probe, pin 5 is just low. There are no highs on that. And this is the input. So our input is pulsing crazy. And this is always enabled. And our output is low all the time. So this guy's no good. So we will replace this so that this thing can do some addressing. Alright, I've replaced this guy, and the good news is on the outputs, starting right here, that's an output, and output, output, output. You can see they're all looking good. So all of our outputs are looking like signals now, so that's good. We're still nothing on the screen. It went to a little more of a tint of blue, light blue, turquoise almost, really light, super light turquoise. And if we put it over to the other monitor, it is dark purple-ish. So we're still not getting any business going on. I don't know if we've got any because we're not resetting. We're not doing anything, but we're not resetting. So I would like to see if I can use the fluke on this. I'll have to look it up a little bit, look up some info. This looks like it's resetting. But I'm not getting 1, 2, 3, 4, 5, 6. I'm not getting a reset pulse on here, I don't believe. Let's do this. 1, 2, 3, 4, 5, 6. No, we're not getting any reset. I don't know what that's all about. Anyway, yeah, I'm going to go ahead and I'm going to look up fluke information, see if I can't put the fluke on this and try to read these EPROMs. They're 27, 128. 2764, 64, 64, and a 128. So yeah, I'm just curious whether I can read those or not. There's EPROMs on these too, but I don't think these game cartridge things have anything to do with it. For right now, I think this is all a hardware problem. So I will go ahead and look up some fluke stuff and see if I can do RAM and ROM checks. Alright. Okie dokie. Well, I wanted to figure some decoding, and I wanted to look at what makes 8V fire. 8V is a 6116. It's a slim 6116 RAM. And I wanted to check that guy out because all of the ROMs are good. I dumped all of the ROMs, and there's only one main CPU ROM, and it's the 128 at 8T. And then there's a RAM that the CPU gets to, that's 8V. And I wanted to, since there's no MAME virtual machine on TechNet's website, I needed to figure the decoding out myself. I needed to figure out the address range myself. So I just went through this and went, you know, it's well documented out here. You got address 15. So this guy 6T, the high side of 6T here needs to fire Y0, right? Because Y0, when it goes low, it enables the low side of 6T, which pin 4 Y0 fires my RAM 8V. So I need to backtrack. Okay, well, we know that A and B, address 11 and 12 need to be 0 because we were trying to fire Y0 there. And then over here, we want to fire Y0 to enable this guy. So A and B, 13, address 13 and 14 need to be 0. These are the musts. 13 and 14 need to be 0. 11 and 12 need to be 0. Address 15 needs to be 1 because it's getting inverted right here to a 0 to enable the high side of 6T. So 15 needs to be 1, 14 and 13 0, 11 and 12 0. Those are the musts. And after that it doesn't matter. And that's what I have wrote right here. I just kind of wrote this all out and thinked it out. The 6116 at 8V, 15 needs to be 1, 13 and 14 0, 11 and 12 0. And then I just kind of wrote it out. What does that look like? Well, 15 is 1, and then 0 0 0 0. Those are the half twos. And then everything else doesn't matter. Everything else is just the range. So that means that 8V, the range is 8000 to 87FF. 8 0 0 0 to 8, and then the doesn't matters 3 or 7. There's 3 there that don't matter. That can be 1. Those all can be 1. So it's 8 7 FF. So 8000 to 87FF is the range for that RAM. Now let's come back over here. And right now I am doing a looped error RAM short, I guess you would say, at 8000 to 87FF. You go RAM short 8000 to 87FF, and it gives you the error, all bits are bad, and then loop it. And then you can loop that. And I've got me this is the RAM in question right here. I've got me a new 6116 Slim, and if I pop it over there, look at that. There you go. So we have a bad RAM right here. So I'll have to remove it, and it goes back to being goofy. So we'll have to stop and replace that guy right there. All right. New RAM. RAM short, good. Let's try to run it. Still not working. Still something ain't right. So we know that I can get to my ROM, my main CPU ROM. I can read it good. I can do this RAM good. That means my data path for both of those is good. This thing, I don't know about this. I don't know. We'll see about that. I don't know if that's accessible to this or not. be honest. I'll look into that next. There's a RAM right here too. I wonder what that's all about. I don't know. But yeah, so I don't know. I'll keep digging a bit, and if I find something cool, I'll be back. Well, just on a hunch, I placed a RAM, a 6116, over this guy and ran at 8800. 8800, and it just give me that decode. I don't know about that, because if I do this, see, and let's repeat, I loop it. If I take and jump this guy over it, look at that, clears up good. I think I have another bad RAM. I just removed it and it went back to bad. So I'm going to tear it down again and replace this guy. I think this guy is really messed up, and it messes with the decoding even if I jump it. So I think this one's really bad. That's my theory anyway. So let's go ahead and replace that guy. Something awfully curious. I've been coming around to none of this is working. The reset counter isn't working. It's constantly stuck loading. We have no NMI. There's no preset action up here. And everything seems to be revolving around this I/O stuff. This circuitry right here. And I've got no I/O request signal at all. It's always high. So what I did was I lifted pin 20. Right out of the socket, right out of circuit, pin 20. And now if I probe that pin 20, I clearly have a signal. 1, 2, 3, 4, 5, 6. And I now clearly have a reset. (19, 18, 17, 19, 18). I don't have an NMI. But if I take this is where I pulled this out of, pin 20. If I probe pin 13, since this is out of circuit, this should float now, you would think. Pin 13 of 7Y. 7Y is right here. Pin 13 is high. So I'm thinking that this thing is shorted high. So what I want to do is just clip pin 14 and see what happens. I'm going to replace this anyway because that's my suspicion. But I'm going to clip pin 14, put this back in the socket. Well, I decided to just go ahead and jump this RAM. Jump a RAM over that video RAM. And it's doing something. A little progress. That 04 didn't have anything to do with anything. I replaced this and it made no difference at all. And I've just been messing around with this circuitry right here, watching this as I power up, and this thing seemed to be doing everything it needed to do. But this RAM is definitely no good. If I remove it, it just kind of goes to nonsense. So I'm going to stop and replace this guy right here. And yeah, I just had some really super good cheese. Alright, I'll be back after replacing this guy. Okay, I messed around with some of the dip switches. I actually need to find out what the dip switch settings are for this. But it came up in a test. And I will reset it and you'll see it go through its RAM and ROM checks and stuff like that. It says all the ROMs and RAMs are good and whatnot. So So it's going through its tests. That's very promising. I need to pull the manual for this, or just get the dip switch settings and find out what this thing running is. So let me do that and set these switches so this thing will run. But it looks like our CPU side RAM and ROM problems are beyond us, or behind us now maybe. So yeah, we'll see. Oh, Nintendo PlayChoice 10. How you turn my hair gray. Goodness gracious. I can get the whatchamacallit, the BIOS to come up. And I was thinking maybe it's a software issue, so I burnt another ROM. It's not the ROM, it's not that. So I was like, okay, let's get back to fundamentals. How does this thing work? Number one, I didn't really understand how this worked. This CPU, the Z80, runs all of the, say, the menu, right? And that is driven by this ROM, this menu stuff. But what that Z80 has to do as well is that Z80 has to be able to tell what is here. Is there a game here to put into the menu? Right? I mean, the menu has to have games. How this works is this stuff sits idle. It doesn't really do anything until you select a game. Then that takes over. So what I'm doing here is I looked up this, okay, this Z80 has a direct path, and I will grab the schematic really quick. The Z80 has a direct path. Address 0 through 12 and data 0 through 7. That DD 0 through 7 is the Z80 CPU bus. So it can directly read these ROMs. Now there's this signal INST ROM select that goes down, and that is the ROM select that goes to this thing, you know, the socket. So I got to thinking, I was like, okay, this has to get to this to find out what game is in here, and we'll put that on the menu. So this Z80 has to get data from this ROM to see what it is. Let's put that on the menu. Then you can select, and when you select a game, then the Z80 says, okay, it's all you. It's your show, RP2A03E. You can go now, and this thing starts running the show. You know, so yeah, it's like a handshaking thing. This thing says, okay, hands it off. Boom, now it's all you. But what I got to doing was, and I put a green dot on this chip. I green dotted it. And you're going to see, because I figured the range for this ROM. Because I wanted to figure out what is the range for this ROM, for the Z80 to read this ROM. So I did a little decoding. I did a little address decoding. And you've got address bit 15 is the enable, so that has to be 1 because it's inverted low. So address 15, the most significant address bit, is a 1. Address 14 and 13 right here, we want to trigger INST ROM select, which is the 2-bit 0, 1, 2. So we need 2 on here, so that's going to be 0, 1. 0 on address 14, 13 needs to be address 1. That is, and then address 12 can be 0 to F. So it's going to be A, 1, 0, 1, 0, A, 0, 0, 0 is the address range, A, 0, 0, 0, and it's a 2764 that we're trying to get to, and that is a 0 to 1 FFF ROM. So our address range for this ROM is A000 to BFFF. That is directly accessible by the Z80 through this decoding. So if I try to read this ROM, just do a read at A000, let's say. Let's do a read at A000. Okay, boom. It says EF. Now, going by this, remember now, this is going to be 101. You know, 1, 0, least significant bit needs to be 0, and the most significant bit here needs to be 1. That is binary 2. Most significant bit, least significant bit. 1, 0, 2. 0, 1, 2. That will fire. Where am I? That will fire this guy, which is our signal that we are trying to trigger. ROM select 0, 1, 2. 1, 0, 1. A. Right? So when I'm doing A, and if we look, this is how I set this up. My analyzer. These are your bits. Least to most significant. The LS139 will rest with the bits all at 1. And it drives low. It's like an enable decoder. It's an enable bit decoder. It sends bits low based on the address. And we already know that LS139, if we put a 1 on address 15, a 0 on address 14, and a 1 on address 13, and then, you know, address 12 doesn't matter, so we can say 0. That is 10 in binary, which is A in hex. A000. Right? Now I'm reading at A000, and that's going to send that second decoder bit low right here. This is what's going to read on the analyzer. 1011 equals B in hex. Right? Now I've got this all hooked up. I've got my least significant, 0. This should be 1. Nope. One is my least significant bit. So this should be on my least significant bit is pin 14. So let me check out. I might have this hooked up wrong, and this might be all for naught. I think I may have made a breakthrough. I just had the analyzer. I was analyzing a 139 again, and it was fine. And I got the decoding for the ROM on these guys. It's C000 to DFFF, because it's a 2764. Now I did not go through the schematic about how it selects channels yet. I know it's through one of these latches, so it's software driven. But as far as getting to the ROM on here, that's pretty trivial. I mean, the Z80 has direct access through the addressing and the data. That 80 through 12 and DD0 through 12, that's straight CPU bus. But I think I have made a breakthrough on this thing, because I was having issues getting over to the ROM on this thing. I pulled it and whatever. Anyway, I've got a 245 jumped over this guy right now, and I've got no ROM in that socket, and I'm just doing a repeated loop reading at address 0. And what I should have is a solid FF. just like that. If I remove this, look at it. See that? That 245 is no good. It's just flaky. It's just weird because I can do... This was the thing that was tricky about this, is I can do my ROM checks, my RAM checks and stuff, no problem. But this thing is flaky. It is absolutely flaky. That's no good. You can see that F, I saw A, that's 2 zeros in there. I'm seeing A a lot. Just for kicks, I'll try to do this. It's kind of tough. I think I got it on there pretty good. Nah, it's even worse. If I kind of hold that, it's solid. But the moment I take my hand off of it, see ya. Yeah, this is just flaky. So I am going to stop and remove that, replace it, put the fluke back on it, and do this test all over again. And hopefully this will be straightened out. Alright, I had replaced that 245, and much to my dismay, it was still flaky. So what I did was I went over the schematic and looked at everything that was connected to the data bus, the direct data bus. I think that's what that stands for. Direct data bus, DD0 through DD7. And there were just a few things. The major thing was these guys. All of these 240s are all connected to the data bus. So I cut them all right out of the board. And I am now running that same test, looping the read, and there's no flakiness. So at least one of those 240s was flaky. So we'll replace all three of them. No big deal. Alright. Very good. Be right back.